just did is I ran my finger around the screen of my iPad. Okay? So what you can imagine, then so what you're seeing here are fluid particles of some type. Call it. So I guess it would, if it were blood, this would be a Vulcan, right? Anyway. What I want to show you is different types of flow. So this first one is going to be so as the fluid goes around, now you'll notice that the particles, the flow close to the corners there, they certainly don't stay together. There's a lot of curling around and fiddling around and fluting around, and that's not smooth flow. But as you move away from it, notice that this stream here, this second stream out there, they are hardly affected at all. A little bit, but not very much, okay? And then the further out you get away from the barrier, the less affected there is. And so, although the two streams closest to my barrier that I drew absolutely are not flowing smoothly, the ones next, a little further out are flowing nice and smoothly. And that's what I'm talking about when I talk about smooth flow or laminar flow. Okay, and the thing I drew with the square had these sharp corners, but if I draw something that's more rounded, notice that even close up to it, it's still fairly smooth. This is what they want to do with cars, particularly electric cars, to get the best mileage out of them, to use the least amount of energy as they move around. Okay, so you can imagine a car, actually, let me do this. See what does a car look like here. So the car is going upward. So notice that drawn the way I have, although there's a lot of screwing up with the air because as it moves through the tires, look what's happening to the air just going over the roof. If you had a car that was shaped like this, you'd never get a date. But at least you get good gas mileage. Okay? So, that's laminar flow. Okay so far?
Just made
I was gonna say, your lack of reaction tells me that, yeah, we know about not getting dates. Yeah. All right, the next one, and in the interest of doing things, I'm going to not turn on the lights. I'm not going to write on the board. Okay. So now let me draw a tube here. Make that a little narrower. Okay. So, yeah, this still didn't give me what I wanted. Let me see if I can do something. Yeah, that's what I want. Okay. So, I know for you guys on screen, online, this is really hard to see. But what's happening up here is, I wonder if I can freeze it. Notice that as the particles go in, you get they sort of get, they form this sort of parabolic shape almost. But the way this is described, the shape of the fluid as it first enters this tube, it actually forms a shape that you can think of as a plug. You know, you like plug a pipe or plug a tube, okay? And so the flow there at the entrance to the tube is called plug flow, okay? But further down, as it becomes more parabolic shape, then, so the plug flow is what you get right at the entrance to a tube. And then further down, as it really does take the shape of a parabola, we get parabolic flow, okay? Now, see if, I like playing with my choice. Okay, yeah, this is not bad. Take a look at, see if you guys here, so you can see this. Right here. Take a look at this region right here. Okay, now this region here is clearly not laminar, it's not plugged, it's not parabolic, anything else. It's basically screwed up, right? Maybe there's different ways to visualize it. So, yeah, this is even nicer. Yeah, it's mostly going through, but the flow is highly disturbed, yeah? And in fact, that's what it's called. This is called disturbed flow. Okay? Now, this often happens inside the human body, and it also happens inside the plumbing in your house, because the pipes that come into your house are typically, 3-4 inches in diameter, but the pipes that are going to your bathroom sink are probably a 3/4 of an inch or a 1/2 inch in diameter, right? And so the water in your plumbing is going from big fat pipes into little tiny pipes like this, and so you do get this disturbed flow in your pipes. Now, okay, now let me do this. Your plumbing in your house and the plumbing in your circulatory system can often do something like this. Okay. Now, if you take a look at what's happening in here, and maybe it'll look better like this. Let's see. Well, however you want to visualize it, look inside the tube. Up here, the flow is kind of nice and laminar. Here, the thing's narrow and it goes up here. Look at what's happening, first of all, up here. There's very little flow up there. And then right here, notice that the particles are just kind of sitting there. They're barely making their way around. They're sitting there mostly spinning around, okay? And we can, oops, let's try with this. So the fluid comes in, and it makes its way around, and then it's not as nice as I hoped it would be, but I'm trying to make it nice and visual for you here, but it's. Anyway, right here, the particles just sort of sit and spin. Now, if you imagine that these are red blood cells, you know what red blood cells do? They carry oxygen to different parts of the body. Well, if you get something like this, the red blood cells are sitting there spinning, and they're giving up their oxygen. See, they slow down here, they give up their oxygen, and by the time they make it to wherever they're supposed to be going, they don't have any oxygen anymore. Okay? This kind of flow, where they just kind of sits there and nothing really useful happens, there's very, very little flow, and they just kind of sit and spin there, is called either turbulent flow, or in the worst case, chaotic flow. Okay? And so, yeah, and if you have this app or want to get something like it, it's you can do all sorts of experiments. With it.
So there was a laminar, disturbed, chaotic,
And turbulent.
turbulent?
Yeah. And they are all interesting in their different ways. Right here we have definitely turbulent flow. What this is right here, this is called an eddy current, or just an eddy, where the particles are simply sitting there spinning around and never actually getting anywhere. And this is a really dangerous medical condition, as I say. These blood cells have long since given up their oxygen, and they're just sitting there, and they're not circulating, they're not getting any new oxygen, they're not going anywhere. It's just bad news all the way around. So yeah, so this is so different kinds of flow. The next task ahead of us then is, now that we have a sort of a mental grip on what kind of flows you can get, what can we calculate, can we characterize these types of flows, and how do we calculate it? And that'll be our task for tomorrow. We'll calculate those things, we'll get a bunch of equations, and in the second half of tomorrow, I will tear the roof off of your house.
Yes.
You're welcome. Any questions?
I need a new one.
Oh, I'm not going to replace it, I'll just tear it off.
Okay.
Okay, good. Have to work. Okay, watch your eyes, lights are coming on.